All right. Oh, it's been a little while since I posted the last video. Um, Go back to your codepen.io webpage, log in. Use forgot password if you forgot your password, of course. And then click on your 100 students problem code that we had been working on. I will get rid of this ad. Sure. So, where were we last time? Well, if you remember right, we'd actually coded up 3 of the 4 algorithms we were going to try. We had random, which was just go in and have somebody randomly pick 50 boxes. They might accidentally pick the same one twice. Each student out of the 100 is picking 50 random boxes. And again, they might pick box 3 the first time and then forget they picked box 3 and like the 43rd box and pick it again. And that's that. Random with memory is like, let's assume the students can at least remember that, which 50 numbers they've picked or which of the previous numbers they picked so they don't pick them again and actually pick 50 unique boxes. That's pushing it a little bit for human memory, but maybe. Especially if you move down the line or something, like so that you always pick them in increasing order. I feel like that's reasonable. And then there was first half. First half said have students 1 through 50 pick the first 50 boxes. They just all open them in sequence, 1 through 50. Hopefully the number's there. And the cool thing about that one was, random with memory was obviously better than pure random because you aren't picking the same box twice. First half was even better because if the first 50 students succeeded, which is very remote chance, but if they did, the next 50 have to succeed, right? If the numbers 1 through 50 are somehow in boxes 1 through 50, that means numbers 51 through 100 are in boxes 51 through 100. So students 51 through 100 come in and choose the second half of the boxes, they'll immediately win. So those were our 3 strategies. Now, I want to actually get a little bit more visual this time and kind of see, like, we saw how random did do worse than random with memory, and random with memory did worse than first half. I kind of want to actually show how many students are actually on average winning. Like right now we're reporting just did all of the students succeed or fail? And while that's nice, it would be kind of cool to see, with one of these strategies, did 99 students out of the 100 succeed and 1 fail, or did like 12 succeed and 88 fail, or what was going on here? So that's what we're going to add right now, is just a visualization to help us see that. So what are we going to do? The first thing I want to do is add one more input box up here. I have number of students, but I actually want to add another box that says the number of students I want to win. That has always been the same as number of students up till now. I actually want to start asking the question, well, what's the probability if only 50 of them won? Or 20 of, I only require 20 of them to win for, them to get the $10,000 prize if the teacher's feeling incredibly generous. Like, I'm not going to make you all win. Just I want some number of you to win. So I want to be able to simulate that. I want to be able to enter in a different number of students I want to win than the total number of students. So I'm just going to add that right here. I'm going to go up in my HTML, make another paragraph tag, and say number of students that must win. Yay. We're going to make another input, like usual. I'll call this one ID, and I'm just copying the line above if you notice this. ID equals, and I'm going to say num students, but then must win. I'm just going to give that a few more letters. I'm just coming up with some name for this. So this one's number of students. This one's num students must win. And then this is, again, type number. I'm just kind of copying the line before this. And the default value is going to be 100, just like last time, because by default, we probably want it to be the same number. So I just saved there so that it would stop being angry here. Close that. So now you can see, yay, I have number of students is 100, number of students that must win is 100. That's the normal game we play. If I change this to 50, then this should also, be changed to 50 or something less, obviously. Like if I say number of students 50 and leave this at 100, it's going to be hard for 100 students to win when you only allow 50 to play the game. So the probability is definitely 0. Nothing interesting is going to happen there. So yeah, you'd want to change these. So I've made my box, but I haven't used it yet. Let's go do that next. I'm going to go down in my JavaScript, and I am going to go down to my run function here. So notice at the top of our run function, like we've been doing, we always just grab certain values with document.getElementById. This has been our standard way to grab values from the HTML page and get them into JavaScript. This is going to be no different. We're going to, again, basically copy the previous line. I'm going to make const num students must win. I'm just naming this something in JavaScript. It's just nice if I name it something similar to what I gave as the ID up here so that it's not too confusing, but completely up to you. Normally, right, we could do document.getElementById num students must win. And notice this is the dash version here. Put a semicolon at the end of that to end the line. So like normally this is the basic version of this, right? We just grab the element by ID, and this gives us the entire box here, and then we do this dot value thing, right? That gives us the value inside this box. But remember, just like we did up here, this needs to be an actual number, and by default, JavaScript returns a string here. It just gives us the number 100 in quotes. So if we added 1 to that, it would say, of course you want 100 plus the extra 1 tacked on the end of that string to get 1001 rather than 101. So that's no good. Again, JavaScript numbers need to be numbers. Parse int will turn that into a valid number, and I put the end parenthesis bracket there. And notice that is what I had done on the previous line. I was just calling that out, that yes, we need that here too, because this is a number. Notice the strategy was not a number. So for instance, we didn't have parse int here. We just had the dot value. So anyway, yeah. Okay, so now we actually have the number. This, if I type in 50 here and then hit run, num students must win will be 50 now. So we have a variable that holds this value. We've kind of connected the HTML to the JavaScript like we usually do. And now we want to come down here and change the condition for winning. Notice down here we said play one game if the, how many students won. Like our function already returned, and this is kind of why I did it this way. Our function already returned how many of the students actually won. Did 50 win? Did 94 win? Did 100 win? That kind of thing. And the way we said, did the whole student group actually win was, did this function play one game? Did the number of students who actually won equal the total number of students? If 100 students won and 100 students were playing, that was a win in the real definition of the game. So let's change that. Let's say if the number of students that won is greater than or equal to the number of students that must win. Remember, this is the variable we just created up here. Num students must win. So this says if this is 50, and we had 50 or 52 or 73 students that won, count it as a win. But if it was 49 or under, that greater than or equal to statement will be false, right? 49 is not greater than or equal to 50, and therefore it will not run this code inside the curly braces. So num wins, does not get incremented there, and that's that. Now there's one more thing that actually needs to be done before we can test this out. If you may or may not remember, I almost didn't remember. Well, I didn't until I tried this out. Down here, we took a bit of an optimization, a very reasonable one. While we're playing the game, if we hit a single failure here, so we say play one game for student, and if that returns 0, they did not find their box, we immediately return s-1 is the number of students that won. So the idea is, if the first student plays and wins, we come through the loop, come back, s equals 2 now. Let's say the second student loses. Okay, That's fine. But this immediately says, okay, they failed. There's no possible reason for us to continue playing games because everybody had to win in order for anybody to win. So just return 2 minus 1, i.e. one student won the game, the second student failed. Be done with it. That's not true anymore, right? We actually need to keep playing at least until, like, if this is 50 students here, or let's say 40 students, just to make the math be nicer, to keep it separable. So let's say 40 students have to win. That means I should play until at least 60 students have failed, right? Like, on the 61st student failing, I now know that no, 40 students cannot win, and I should quit. But up to 60 students failing, I should still be playing this game because it's still possible 40 students might win. We should not just bail after the first mistake. So that's what I'm going to do. Instead of just immediately returning, I'm going to actually ask that question. Is there still a reason to keep playing? So one thing I need to do here, first of all, is I'm going to track how many times we've lost, because I haven't been tracking that so far. It was easy here to just say, well, I've won S minus 1 times, first loss, done, no big deal. So I'm going to set let losses equal 0. We start off with 0 losses, and let's actually track them. So in here, we know we've lost, and if you remember right, losses plus plus is how we say that. So that'll, every time we lose, we will say, okay, increment this counter for how many times we've lost the game. So now I don't really want to return S minus 1 anymore. What I want to do, I'm going to delete that line, is say, you know what, if this condition we're talking about, if 61 of my students have lost the game and I only wanted 40 to win, that kind of thing, like, if that's true, and I'll type that condition in a moment, type my curly braces, then I want to return the number of students minus the number of losses. I could have tracked wins instead, but this is the same thing, right? The number of students is going to be divided between losses as part of it and wins as the other part. I'm already tracking losses for my purposes here. So I said number of students minus losses is the number of wins I've had so far. Fine. I could have tracked wins too. So either way, I would just had to have had an else condition, and I didn't feel like it. So you can go either way you want with that one. So yeah, return number of students losses. I have to do that at the same. I have to do that same thing at the end too, right? When I get down here, I may have lost the game a lot of times. It's no longer true that I definitely have all the students winning if I get down to this point, right? If I get through this loop, I may have still had losses. Get to the bottom, I need to subtract them out to say how many students actually won. Okay, so that's good. I just need to come up with my condition now. Well, the answer is num students minus losses is less than num students must win. Now, we're going to fix that in a second, because notice num students must win isn't defined here. It's actually defined in the other function up here. So this function doesn't have access to another function's variables. We'll fix that in a moment, but let's just logically think through this. Num students minus losses is the number of wins I have. It is the number of wins I have, but it's basically saying if this is less than the number of students that must win, that's actually how many that are left that can win at any moment. So if I have 100 students and 61 of them have already lost, I subtract 161 and get 39 that could possibly still win yet. It doesn't even tell me how many wins I have. That's kind of why I wanted to track it this way. It tells me how many could possibly win the rest of the way through. And that has to be, if it's less, if it ever drops under the number of students that must win. So the total number that could possibly win, still 39, is actually less than 40, the number that I want to win. Just return 39. Notice it's not accurate, right? It's going to, it's just drawing a cutoff and saying, okay, assume maybe 39 students won. It's the best that could have happened, but it certainly is under 40, so I don't really care. Because you told me 40 have to win. I'm going to cut the line. Only 39 could possibly win left. We're done. Okay. So all that to say, this variable isn't valid yet until I do something with it. I could just copy this here and paste it down here to again grab it from HTML. Slightly easier, in my opinion, is just to pass this variable here, num students must win, into the function. So I'm going to add that as a third function parameter. Must win. Num students must win. Okay. And now I need to find out where I'm calling play one game up here. Oops. It's right here. Sorry. And then add num students must win here. So what this does is this kind of what they call pipes it through. If you look at this, this is defined here. Num students must win. Num students must win. And it calls play one game with that variable. That variable is passed, the same exact value is passed down here. And now we can actually do the comparison because we have access to that variable function. Okay, let's see how this works. When I click run here, you can see nothing is happening. Yay. I mean, well, things are happening. It's just we're getting 0% chance of winning as expected. If I drop this down to 50, notice I'm getting some wins here. Not a lot, but I am getting some wins. About 2% of the people, or 2% of the games are considered a win. Again, because now a win is considered 50 students or more winning, right? And like, this is not the real game. This isn't like we found a cool way to get, have the students win. This is the teacher being super nice, and this is not the real game that we're gonna figure out the 30% plus solution to it a little bit. Okay. So all that's nice. Yay. If I put this down to 0, you'll see, yes, 100% of the people win if you don't require anybody to win. This is like the game you play with, like, your kindergartners. They're like, oh, we all won. Everyone gets a lollipop instead of $10,000. So, but yeah, 20, a lot of people are going to win, right? Like still actually about 100%. It's actually very rare for like 20 people to actually lose the game. If I put this back to 50, you'll just notice, yes, random with memory is still better, a lot better, 54 roughly percent of people winning there. At the moment, first half is even a little higher. It's like 57, 58. So yeah, these two methods are doing a lot better for getting 50 or more students winning. Okay, so I want to do one more thing because like I could try to figure out, okay, what's the chance of each of the numbers coming up? Like what's the chance of 49 coming up? What's the chance of 50 coming up? What's the chance of 51 as far as number of students that won? I could just keep changing this number and kind of saying, well, and doing some math to figure out like basically what the bar chart would look like here. Like how many times did 51 people win? I don't want to do math. I want the computer to do math. Let's have the computer do math. So what we're going to do here is we're going to actually add up at the top in the run function, above our loop, we're going to say, let student wins equal a new array. I'm actually going to track all 101 possibilities here. So I'm going to put my brackets here. Why do I say 101? Num students plus 1. Put my semicolon here. Because there are actually 101 different outcomes of this game in terms of number of students that won. You can have 0 students win, 1 student win, all the way up through 100. Unlike our normal arrays where we were talking about 0 to 99 or 1 to 100, it was always 100 elements. But now it's actually 0 to 100 is the possibilities. So it's just something you have to track. We have to track 101 entries. So new array num students plus 1 is going to create an array that's indexed. You access the elements in it by numbers starting at 0 like normal. So it's going to be 0 up through 100, which is 101 total buckets. But notice it exactly lines up with what we want to track. We do want to track if they win zero, like 0 students win, very sad day. 100 students win, very happy day, that kind of thing, and everything in between. There's one more thing though I need to do to my array. This has created, if you remember right from arrays, there's just a list of elements, and I want to make sure these all start out at 0 so that I can add to them. Every time a student wins, I want to say like 20 students won this game. So go to bucket 20, like element 20 in this array, and add 1 to it, right? If 0 was there before, then now 1 time we've seen 20 students win. If it happens again later, we want to add 1 to that 1 and get 2, and add 1 to that 2 and get 3, so forth, as you keep seeing 20 students win, let's say. So that's kind of what we're going to do. We're just going to have this tracking list of 101 numbers and just go in there and add 1 to every time we see that number of students win. We're just going to increment that spot. So I do need to start it at 0, or else weird things might happen. All right. So now in the loop, right, I actually see each time I go through this loop, remember num iterations here? That's going through the game 10,000 times, or however many times I type here, 100,000. And so each time we run this code, this is 1 game. And I see how many students won that game. So I actually want to go into this student wins array at the position of students 1. If students 1 was 20, I want to go into the box 20 and just add 1 to it. So that means I say student wins, which is my list up here. And then I say square bracket students 1. That says go into, if students 1 is 20, go into bucket 20, element 20. Or if 0 students won, go into bucket 0. Or 100, bucket 100. And then I just want you to increment that. Yes, that actually is valid to do. I could just say, if I wanted to be really long-winded, equals that plus 1. So this would take, go look in the bucket, add 1 to the thing in the bucket, shove it back in the bucket, is what this says. Like the equal sign happens last. But plus plus is way shorter, and it does the exact same thing. That's why they made it. All right. Last piece. Let's actually look at what this looks like. I'm going to do a console.log here. Student wins. Let's just look at this array, and notice I'm putting this outside the for loop. I want to play all the games first and then look at that big bucket of 101 numbers. All right, let's run this and see what happens. I hit run, console. Let me clear that out because there's a bunch of errors in there. Run. Okay, so notice this is the sad version of the game, right? I said I expect 100 students to win, which means our code is still giving up when it hits 99. Like when one person loses, it still gives up because it knows there's no way 100 can win anymore. So notice it piled all 10,000 entries onto the 99th block. Well, it's the 100th block. It's 0 through 100. That's position 99. And notice position 100 is 0. Nobody won the game as we expect. I'll back this down to 10 just so we can see what's happening here a bit better. If I click run there, I have to scroll back over. Notice still the same thing happened, right? Nobody actually won the game. And then 10,000 people immediately early returned as like, well, who knows? At most 9 people could have won the game still. So like, whatever. All right, fine. Let's back this down now to 0. Now, why am I doing 0? Yes, that's going to make 100% of the people win, but what it will do is it will never early return from this code down here. So if you go down here, if number of students minus losses is less than number of students must win, number of students must win is 0. That will never happen. We will never return early. We will play all the games, and we will return how many actually won. So that will actually correctly fill this list of numbers. Yay. And you can see if I run this a few different times, I get, multiple different, numbers, but they're roughly in line with each other. You can see it very rarely with random are you ever getting a win, but you do, even with 10 students. A lot of times, no students are winning, but it's still way less likely than, this kind of middle section. So, cool. that gets us part of the way there. This is kind of what I wanted to see. How likely is it that you'll get 0 wins, 0 wins, 1 win, 2 wins, 3 wins, 4 wins, 5 wins, 6 wins, 7 wins, etc., off of a 10-student game. I get a feeling for how likely each position is. I could continue to do this with the other strategies, but I want to actually finish off by adding a bar chart literally so that we can see it rather than stare at a console. So I'll clear the console and close this, and we'll now add the chart. So this is one cool thing that CodePen gives us. They have an assets tab thing down here. So we can click on packages here because it's under the free resources. And I can just be like, I want a chart, thing. Now, I don't know, maybe these are all fine. Things I'm looking for when I look at this list, I like the word popular here. That tells me a lot of people have been able to use this and it's worked for them. I also like the word simple down here too. That's a good combination. So I'm going to go with this one. This one ends up being pretty easy to use as opposed to some of the other ones are a little bit more advanced. I'm going to click the script button down here. Notice it has this esm.sh thing. That's good. It's a little more advanced in usage because you have to declare kind of the things that you're using from that package. And I'm just going to include the whole thing. We don't need to get fancy here for optimizing our load times or anything. So if I click script, notice it has this script thing here. And I click copy. And then I just click off of it back up into here. I go to the top of my HTML and give myself a little bit of space. And then I paste and save. So what this has done is script is an HTML tag that actually says, hey, I want you to actually grab a JavaScript file from somewhere else and just put it at the front of my web page, basically at this point, so that I can use some functions that other people have defined in my JavaScript. So that's what this chart thing does. If you notice, this is a website address where they've put this JavaScript library that has chart functions in it for us, so we don't have to make our own charts and draw things. Yay, that's good. Where are we going to draw it, though? Well, we're going to learn about one more HTML tag while we're at it. If I scroll to the bottom here, I'll just, at the bottom, make a div tag here, and then close that div tag. We're going to learn about the canvas tag. So canvas just lets you put graphics on it. It is kind of like an art canvas. You can just draw things on it. Lots of libraries work with it. The chart library is one of them. It expects a canvas, so we're going to give it a canvas. I do need to give it an ID, just like everything I want to access from JavaScript. I'm going to call this student wins. And then just close the canvas tag. It's one of those kind of deals where you just, that's it. Okay, so it's completely empty. Notice I can't see anything, but it's there, and I need to point my chart at it, my chart library at it, so that I can start drawing things. So let's do that now. So let's go up to the top of our JavaScript. Scroll up here. And we're going to add in some control of this canvas and try to use this chart library and plug it into this canvas effectively. The first thing I'm going to do is the very standard thing here. Add a line. And I'm going to type const. And I'm just going to call it canvas in my JavaScript file too. Again, I could call this anything I want, but I'm just going to say the canvas that I want you to work with. There's only one of them. Document.get element by ID. And if you remember right, the ID is student wins up here. So student wins. Semicolon. Cool. So now my JavaScript has a variable with this canvas tag linked to it. Now I need to create some sample data. Now this is something I had to look up how to do online. It's just a kind of particular format, and I'm going to explain it a little bit, but I'm just going to type first just so you can see what I'm doing. Let chart data. So we're just making another variable with our chart data. We're going to do curly braces here. More on that in a moment. Labels 0, 1. So that's going to be the labels on my bar graph at the bottom. And data sets, square brackets, and curly brackets inside that. What the heck is going on? Who knows? All right, we'll talk about that in a moment. But let's actually just see something work and then talk about it. So I've made my chart data, but I haven't done anything with it yet. So let's do const student wins chart. This is the actual chart that's going to show up. Equals new chart. This is the piece that JavaScript up here at the top. It pulled in an object called chart. So I can say new chart. This wouldn't work if I didn't have this library imported. So the thing I'm going to give it, I'm going to give it my canvas that I created up here, right? So I say, take this canvas, which is the one I defined down here and grabbed via the student wins ID. So this canvas is now linked to this chart. And another curly brace, I'm going to hit enter there. Type bar, not that it matters, and data chart data. This is how I'm linking it to here, right? I'm saying use this chart data I defined, make it a bar chart, link it to this canvas, assign it a variable because I'm going to need to call update on it later to get it to refresh the chart when I change the data. So that's what this variable name is for. Notice what it did. It drew some stuff. Nothing horribly useful, but notice my two labels are there. 0 and 1 are there. If I made this 0 and 15, and then notice that changes to a 15. So there's several weirdnesses, like what's this undefined thing? Why are there decimals here? That's really weird. We're going to sort all that out next, but I first want to explain what this chart data and basically these curly brace things are. So you might be wondering what the big deal is. We've seen curly braces before. There is some on these functions. There's some on these for statements and if statements down here somewhere, wherever they, yeah, these if statements. Like we've seen curly braces all over the place. What's the big deal? The answer is there's no if or for or function in front of these. They are actually something different, but they use curly braces too. Who knew? So this is called an object. If you see curly braces without one of these constructs like for, if, or whatever, where you're actually saying this is a block of code, then this is something called an object. An object has properties. This is a property, and this is a property. Basically, a property is this, key is what they call this thing before the colon, and then the value is the thing after the colon. And it links key to value. That's what it is. So chart data dot labels would be the list 0 and 15. Chart data dot data sets would be this weird list of empty bracket or empty curly braces. This empty curly braces is itself another object. We're going to fill it in a little bit. But the idea behind objects is it's kind of cool if you can have a bunch of variables and even functions nested in the same kind of block. They're all kind of together. This is something called object-oriented programming. I'm not going to go into it a whole lot right now because we don't need to. But the idea is that labels is like a variable and data sets is like a variable, and I can actually access them by saying chart set dot labels. So that accesses the labels, and this would print 0, 15 if I ran that, or if I console.logged that, I should say. Okay, so that's what's going on with these curly braces. This is an object, has two variables or keys inside of it is what they call them inside objects, labels and data sets, but they're just like variables. They're just inside the object. Labels, data sets are the two keys. The two values are the list of 0 and 15 and the list of an empty object. So yay. And then down here, same thing. This curly brace is yet again an object with two keys inside of it. Type, which has the value bar, and data, which has the value of our entire object called chart, like put in the chart data variable. So there's like objects within objects within objects, right? Like, yay, this is probably mind-numbing to some degree. But the cool thing is, if you just put this format down, you can have a bar chart drawn for you without really having to think too much about it. I want to actually get some data in my data set just to see some bars now, because this is a bar chart. So let's add that now to this object. So what you want to do here is hit enter, and then say data. That's the variable it's expecting here. And let's just give it like the values 10 and 20, and then save that. Wow, look at that. So you can see here, label 0 over here got associated with data value 10. There it is, 10. And you hover over it, and it even gives you 10. And then label 15, the second label, we're just pairing these up one by one. 15 gets the value of 20. That's what happened here. It still says the word undefined, which is a little weird. Let's name that something a little better. I'm going to come down here and then say the label for this data is student wins. Now you'll notice I'm putting commas between my properties, right? Up here, this one has a comma after it because there's another property after it. The thing with the key and the colon is the new property, and I need to separate them by commas. You can actually put a trailing comma after every property if you want. This is actually kind of nice because it makes it so that if you magically add a new third thing, you don't forget the comma, right? Like if there's no comma here, I'm like, other thing, colon, it's going to error out because you're like, there's no comma here if you forgot the comma. So I'll just leave the comma. That's nice. Notice it died for a second there and then came back. Okay, cool. We have student wins here now. So that actually is telling me, oops, notice I can click this to actually like hide that data point if I want. I only have one data point. Just as an interesting point of interest, but we're going to delete it in a second just so you can see how this works. Notice this is a list of objects. I can have more than one of these in here if I want multiple bar charts. So label, student, I don't know, money. Like if I wanted like other data points, like, you know, $100, $20, who knows. So notice what that does now. It plotted it on the same y-axis. I could have it on a separate right y-axis if I wanted to. There's a lot of things this chart library can do, but notice that you can actually have multiple bars for each of your labels. And yes, you can hide them if you don't want to see them by just clicking on them. So this is something really nice. This chart library gives us all this and gives us really kind of cool animations too, in my opinion. So yay, and it like auto scaled the graph to 100 when I added 100 in there. Very cool. So I'm just gonna get rid of all this stuff. We don't need it. We just want our student wins. Okay, we've got test data in here. But the next thing is we actually want to add real data, right? So let's do that now. So we don't really want, you know, 0 and 15 as my data labels. I want like 0, 1, 2, 3, all the way to the number of students, 100, right? I want to see a label for each possible number of students that won a single game and see a bar chart that says, you know, 15 times we saw 20 wins and 16 times we saw 21 wins and things like that, you know. So let's go down here where we actually are running our simulation. And let's, at the bottom here, add a little bit of code to do that. So I'm going to say let labels equals new array. Oh, sorry. Yeah. There we go. Num students plus 1. So this is very similar to the student wins. I've made another array of 101 elements if number of students is 100. But this time I just want to fill it with the numbers 0 through 100. I don't want to fill it with, like we did up here. This, we filled it with all zeros and then started adding 1 every time we saw 20 wins or 40 wins or 32 wins or whatever. We just add 1 to that slot, and then that will give us our, you know, our bar chart basically. So here I need to go fill this with the numbers 0 through 100. I'm just going to do that with a for loop. It's good to get the practice. For let I equals 0, I is less than num students plus 1. We have to go 0 to 100, which means we have to go up through I being less than 101, i.e. 100 will be the last thing that works, and then 101 it'll stop and not run. I++, very standard loop. Curly braces that do not mean an object, but mean, well, I mean, they basically just hold code for for loops and if statements. And this is going to be a very boring statement, but labels I equals I. What this says is, in bucket 0, shove the number 0. In bucket 1, shove the number 1. In bucket 2, shove the number 2, and so forth. Like 0, 1, 2, 3, 4, blah, blah, blah. And then after this is done, remember what I said about chart data dot labels actually accessing up here at the top? Chart data dot labels is accessing this variable. We're going to overwrite this with this 0 through 100 set of labels that we just created. Go back down here. Equals labels, the variable I just made. I just made this entire array of a 0 through 100, buckets 0 through 100 that contain the numbers 0 through 100. And then I say, okay, update the chart data dot labels to have labels. If I click run, it does nothing. That is sad because there's one more thing that we need to do. And that's that. If you remember right, I said we needed to call update on this chart when we update the data. So this student wins chart thing, that we need to call update on every time we change chart data, because otherwise it gets lazy and it doesn't look at it. Because why would it? It doesn't want to waste your computer processor. So it's just going to wait till you call it to say, hey, by the way, data's updated. Go do something about that. Draw it in this case. So called that variable was student wins chart. That was the thing I was just looking at. I'm going to call the update method, again, empty brackets there or parentheses. And now when I click run, notice what happens. All those labels got added, and notice it intelligently tilted them. It dropped some of the labels because it couldn't fit them all. It's doing all those things we want a bar chart to do. Now notice I still have my two fake data points here, 10 and 20, right? With no other data because I didn't update the data yet. So we should probably do that. So here, I'm going to update the data as well. Now, what does that look like? If we scroll back up here, notice I changed labels. I need to also change data sets, but I need to change the 0th element of this array, right? And even crazier, so I'm going to say dot data sets, bracket 0 to grab this very first thing in the bucket, and then I need to say dot data to get to this little thing. That's the thing I wanted to get to. So again, just running through that, if I have chart data, saying dot data sets selects this. Saying bracket 0 selects the 0th element, which is this. And saying dot data selects this. And that's what I want to say. Set that to the actual buckets where I was tracking how many times students were winning. So if we can remember that, dot data sets, bracket 0, dot data. So if I scroll back up here, dot data sets gets in here. 0 grabs the 0th element here. Remember when we had that comma whatever and my crazy label down here? This would have been bracket 1, would have been bucket 1 of this outer list. So, but we're doing bracket 0 because we only have one of them. And then dot data gets me this data that I'm going to replace. So yay. There we go. And what do I want to set it equal to? Well, the good news is I already have what I wanted to set it equal to. Remember this student wins array? I filled it with a bunch of zeros, and then each time inside here, I incremented the bucket. If 20 students won, I incremented bucket 20. And so I've actually tracked in student wins exactly how many times each position won. We printed it out to the console earlier. So that's what I want. I want to say those are my data values, sorry. And then that should do it. So let's click run. All right, so you see here everything piled on to 99. Again, remember our play one game function stops as soon as the number of students that must win cannot possibly have won. So we said right now 100 students have to win. If even one loses, it still exits early. It says 99 is the max that can win. let's just return 99. That's the max that can win. But it doesn't matter if we say that 99 people won because, 100 didn't win, and that's all we needed to calculate the win numbers. So to get the actual graph, we have to back this down to 0. Basically, we're saying everyone wins. Don't worry about it. We just want to see how many times 20 people won the game, how many times 36 people won the game, that kind of thing. We just want to play it to completion. So basically, no one has to win, just play the game to completion. So let's run that. And wow, that's a better graph. So we can see here that it's pretty likely that about 39 people are going to win this game, maybe 40, I don't know, somewhere around there. And you can see it trails off pretty fast. I mean, there might be little blips here, but it basically is 0 down here. And I can click run on this multiple times, and you'll see the bars change slightly. So that's worth calling out. What we're seeing here is this is a Monte Carlo simulation. If we do 10,000 iterations, there is some variation in each run. This is why it's an estimate of probability. If we go up to 100,000, notice that it takes a little bit longer, but notice that when I run it multiple times, you're getting less variation. That's the entire idea behind Monte Carlo. Run it a bunch of times. If you want more accuracy, run it some more times. So the more times you do this, the law of large numbers kind of pans out, and you get probabilities that should more closely resemble the actual probability. Anyway, notice too, I'll just point this out too. If I click 50, I'll back this deck down to 10,000 so it runs faster. Notice what happens here. Again, just like we showed before, it gets to 40, like all of the data points where 51 students have failed, and therefore the max that can have succeeded is 49. It just ends early and says 49 have won. I don't care because you said 50 have to win, and I'm going to stop tracking at 49 being possibly able to win. So notice there's a ton of probability here, and this is basically the curve that we were seeing before, all the probability from 49 on down to the bottom. And these tiny little points are the much larger points. You can see this is 87. If I go back to 0, 50 is indeed, well, it's 80 this time instead of 87, but that's the idea. Like what you were seeing on 49 was this entire number added together, stacked on this one data point. So yeah, 0 gives us the actual graph that's happening here. Yes, I will also mention that extremely rare things, as you can see here again, Monte Carlo is useless for. If you can never iterate enough times for the thing to happen, like say winning the game with the random strategy, then you can't use Monte Carlo to estimate the probability. Like computers are not fast enough to do this. All right, so let's actually look at some of the other strategies. Random is interesting. Random with memory, watch what happens to the graph. It shifts over a little bit. In fact, this is probably what you were expecting. The peak here of this graph is at 50. That's what I would expect if students are randomly guessing half the boxes. Half of them will get it, half of them won't. The average will be roughly 50 students win the game each time, plus or minus, which is what we're seeing here with this curve. By the way, I believe binomial / normal, like binomial is discrete, normal is what happens if you had infinite students playing this game. So all that to say, don't worry about that. If you've heard those things from statistics, great. If you haven't, this looks like a bell curve for a reason. So anyway, that's what's going on there. But what is going on with random then? Why is random down here? And the answer is students are sometimes picking the same box again. Like they picked box 4 one time, and then 20 some boxes later, they picked it again. Yeah, so basically, we're actually seeing on average only 40 students make it out with a win on this game. And that's basically due to the fact that they're guessing the same box several times. I guess roughly 10 times? I don't know, something like that. Anyway, let's actually see now what happens with first half. This is our third strategy. Wow, interesting. So you have no probabilities on the odd numbers. We've stacked all of the probabilities onto the even possibilities only. Why? Let's take this down to 10 and think about this for a second. You can see here we only have winners on 0, 2, 4, 6, 8, and 10. And basically, if you think about this, we've told students 1 through 5 to choose the first 5 boxes, students 6 through 10 to choose the second. Imagine what it would take to get only one student winning, this 0 data point down here. You would have to have one of the students, let's just pick one at random, student 2, let's say, actually found their number in one of the first 5 boxes, and none of the other students 1 through 5 did. If there was only one student that was going to win this game, that means all the rest of students 6 through 10 have to fail, right? Student 2 has succeeded, students 1, 3, 4, and 5 failed, and now students 6 through 10 have to fail. The problem is there just aren't enough boxes for students 6 through 10 to fail. So student 2 found their number in the first 5 boxes, which means there's only 4 boxes left that have that can possibly hold the numbers 6 through 10. That means one of the numbers 6 through 10 has to be in the upper boxes, and that student's going to find it, and therefore 2 students are going to win. So while we had used this strategy for trying to pile on data points on the top end, all students winning, it's actually collapsing all of the odd probabilities onto the even ones. And if you look at the difference between random with memory, like notice how this is about 4,000 each. And then these, like you can see, these are about 2,000. This is 2,500. These other data points are down in the 1,200 range, whatever. You might think like, oh, it's like doubling. It's effectively doubling it because it's combining the odd probabilities and the even probabilities. I'll just mention that that is kind of what's happening in the center, but it's not what happens on the edges. On the edges, you have a decent improvement over 2x of this strategy versus random with memory. So if I click this, you'll notice 10 students are winning. I'll run it a few more times. That bar got smaller, that bar got a little bigger. Let's see what it is now, 12. And then first half, 45, 37, 46. We're doing at least 3 or 4x, and actually it's a lot more pronounced with more students. So just first half actually does a lot better for the case where we actually cared about it, which is all the students winning. Cool. So we have our visualization in play. Just a little bit of cleanup here. We don't need this console.log anymore. That's why we did our visualization, so I'm going to delete that. And then I'm also going to go up here, and we don't actually need, you can see this, it goes back to this test data. We don't really need this anymore. We're replacing it every time. So we might as well just show a blank graph until we're ready to show some real data. So I'm going to delete both the labels and the data points, but leave the square braces there just so it just shows a blank graph. And then when we click run, it actually fills it in with a real graph. Well, that's not a very real graph, but if we take that down to 0, we see what we saw before. So with that, we have visualization in play, and now we can actually add our 4th strategy. So that's what we're going to do next time. Until then, have a great day.